Welcome back, students. This is Megasham Raju, Engineering College Bikaner, Assistant Professor in Mechanical Department. And during these lectures, we have seen surface metrology, how to measure the roughness, how to measure the waviness. Roughness is termed as a primary texture of the surface, and waviness is termed as a secondary texture of the surface. In the previous class, we have seen stylus, probe, instrument used to measure the finishness of the surface. So I have explained what is a stylus system, how it will be there, and what are the two types of the stylus systems. And now we'll be seeing popular stylus probe instruments used for measuring surface roughness. In that, one of the popular method used to measure the roughness, from that they will be deciding the finishness of a product, is nothing but a Tomlinsons Surface meter. So before going that, I'll be telling you why there is a need of the surface roughness or finish measurement. Why? Because with more precise development of modern engineering, the control over finish of product with dimensional accuracy has become more important. Fine. Because in modern engineering we require everything precise, everything perfect, right? As it has been proved that the surface structure and surface texture improves greatly the machinability. It has been proved that if we improve the surface texture and surface structure, the machinability of operation of the machine will improve a lot. And the properties like corrosion, resistance, wear resistance, load carrying capacity, lubrication, fatigue resistance, initial tolerance, ability to carry pressure, noise, reduction in gears are influenced by the surface texture. So all these properties in gears or any other product improves the, if we just control these parameters, it will improve the surface texture. For this reason we need to measure the surface roughness, which in turn measure the finishness of the product. Because whatever be the manufacturing process, it is not possible to get a perfectly smooth surface. So small imperfection definitely will be there, and we need to measure those small imperfections. Among that imperfections, roughness, waviness are those important over the surface, which will result in the measurement of a finishness of the product. As I have already discussed, there are two methods to measure the finishness. One is by doing the comparison, which generally we can't rely on that, and the second one is direct measurement. So this Tomlinson surface meter is a direct measurement. So as I have shown you in this presentation, this is the Tomlinson surface meter construction. This is generally a mechanical operator instrument designed by Dr. Tomlinson of the National Physical Laboratory in the UK. So this is the construction of the Tomlinson surface meter. Generally, here you will be having one more part called diamond probe, right? The sensing element is nothing but the stylus, which moves up and down depending on the irregularities over the workpiece. So based upon the irregularities of the workpiece, this will be moving up and down. The stylus is constrained the motion of this stylus. So while while the workpiece is moving horizontally, then there is a chance that the stylus might be moving in other directions. So to restrict that motion, we'll be having an leaf spring with a stiffness or with a force P, where that force P is created here in the main spring, coil spring, and how much the coil spring tension is there, the same tension will be applicable over this leaf spring. These two combined force holds a cross roller, and here you can see a cross roller in position between the stylus and a pair of parallelly fixed rollers. So here you will be having a cross roller and fixed rollers. If you are not clear with this diagram, you can see this fixed roller here. So these are the fixed rollers. So this is an one view of an diagram. If you see the top view, so the two fixed rollers which are firmly holding the stylus, and this is my cross roller or lapped steel cylinder, you can call it. So in between these three your stylus will be placed. So this is my stylus, and this is the so this is the lap steel cylinder. You will be having this lap steel cylinder or your crossed roller, which is in the form of a cylinder, will be here. Okay, and your stylus will be placed in between these crossed rollers and then fixed rollers. Here you can see in this diagram. So these are my fixed rollers, and this is my stylus, and this is my lapped steel cylinder or crossed roller, and then my stylus will be here. Am I clear? So by rotation of this cylinder, which is given by the motion of an stylus, if stylus is rotated, the cylinder will be rotated, and which is firmly held by the fixed rollers. A shoe is attached, generally a shoe or a skid is attached to give a support or a datum for this diamond probe. Required datum for the measurement of the surface roughness. A light spring steel arm is attached. So this arm is attached to the cross roller and carries a diamond tip. So here you will be having one diamond tip over in which whatever irregularities over the workpiece are magnified and then traced over and smoked glass. So this is my smoked glass. So if you just see this diagram, so this is my arm which is connected one of its end to this cylinder and other end to this diamond. Here he is calling it as a scribber, and in my diagram I am calling it as a diamond tip. Both are same. So here you will be having a diamond tip or the diamond scribber, and here you will be having a diamond probe. Remember this. This skid is used to support and give the datum for this stylus. Clear? And now this diamond tip traces the profile of the workpiece on a smoked glass sheet. The glass sheet is transferred to an optical projection and magnified further. So as you have to remember here, whatever the irregularities over the workpiece are very small, so you need to magnify them. So you, after tracing these irregularities over the smoked glass, you need to connect a projector and you need to magnify the traces for a better results. Typically a magnification of the order 50-100 is easily achieved in this instrument. So from this you will be getting an enhanced magnification of this irregularities in this smoked glass. But if it is not enough, then you can connect to an projector and then magnification can be done further. Those magnifications are around 50 to 100 times of these irregularities. In order to get a trace of the surface irregularities, obviously we know that keeping the workpiece at a constant place will not give the continuous irregularities. So the workpiece should be moving parallelly with the stylus movement. In the sense, there should be some relative motion between the workpiece and the stylus. So this relative motion can be achieved by connecting a small electric motor beneath this workpiece, in which there will be a frictionless grooves provided so that the slow movement of this workpiece parallelly with the stylus will give me the entire profile of the roughness of an workpiece. So usually this requirement is met by moving the body of the instrument slowly with a screw driven by electric motor at a very slow speed. Anti-friction guideways are used to provide the friction-free movement in a straight path. That's what I have told. So by motion of the stylus in vertical motion or translation motion, that is transferred to this crossed roller or the cylinder, and which through the arm, in which the motion of the arm is also restricted only for the motion of the arm is also restricted only for the horizontal motion by a leaf spring and also by a coil spring. So these two springs are responsible to restrict the motion of the stylus vertically and the arm at an horizontal. Right guys? So this is what the Tomlinsons Surface meter construction working is there. So tomorrow I'll be explaining one more instrument for the measurement of the finishness, or by measuring the roughness we can calculate the finishness. Thank you.